We've talked about changes in phase, and we said that evaporation, for example, is an example of the water, if we use water as the example, going from a liquid phase to a gas phase. We talked about boiling point. Boiling point is where you add energy in order to make something go from a liquid to a gas. All right, and so we're going to look a little bit at this whole energy concept. We've talked about the specific heat, and each thing has a specific heat, and we said boiling point, you're going to want to convert 1 gram of the substance to how many calories it takes to do that. So when we look at melting, that melting is going to be a solid to a liquid. So we're going to take it from a solid state to a liquid state. And notice that this is a reversible thing. An endothermic process where I have to add heat to it is where I would melt the ice. So it has to release heat or energy when it freezes. Okay? And so this is not super intuitive, so you might have to think about this. It's easy to think about the fact that if you go from a solid to a liquid, like ice, you're melting it, and so usually you have to put heat to it to melt it. Just remember that the reverse process, then, you have to release the heat that's being stored in those liquids so that you can have a lower energy system in the solid. The amount of heat energy needed to melt 1 gram of a substance is called its heat of fusion. The amount of energy needed to melt 1 gram of a substance is the heat of fusion. How much energy in calories is absorbed when 50 grams of ice cubes melt? And the heat of fusion of water is 79.1 calories per gram. So we have 50 grams of water. We want to know how many calories it's going to take. And we have a constant that's got calories and grams. And remember, this is like when we have a constant like this heat of fusion, this is a way to go from one thing to another. It's got both calories and grams in it, so it can take us from grams to calories. We just have to make sure that we've got the right thing on the top and the bottom. So 1 gram over 79.1 calories, or the 79.1 calories over 1 gram, we have to figure out which one is going to get us to the correct place. So we have 50 grams, so I've got to have grams on the bottom. So I'm going to write my heat of fusion, because I'm using it as a conversion, is 79.1 calories over 1 gram. And that's going to give me 3990 calories, because it's 3 significant figures from my measurement of 50 grams. All right, and so it's that simple. So it's just, if you know what the heat of fusion is, it tells you grams, it wants calories. Look at that as a conversion factor, and that'll tell you which way to go in order to calculate this from grams to calories. Converting a liquid to a gas is basically the same thing. It's also something that can be reversed. If you go from a liquid to a gas, it's called vaporization. If you go back from the gas back to the liquid, it's called condensation. All right. Vaporization is an endothermic reaction because I have to add heat to go from liquid water and boil it and make gaseous water, or steam, we call it. And then since that required energy to be put in, I have to get rid of energy, so it's an exothermic in order for me to condense that back. The amount of energy needed to vaporize 1 gram of a substance is called its heat of vaporization. And guess what? Everything has a heat of vaporization constant as well. So when you convert a solid to a gas straight, Okay, and you've seen this in the grocery store because they have things that are in a big cooler usually called dry ice. And dry ice is a solid that is converting directly to a gas. It does not go through the liquid state. That is called sublimation, and that is an endothermic process. It does require energy, quite a bit of energy. And then if you're going to go back from the gas to the solid, you're going to have to get rid of some of that energy, and that's called deposition. So you're deposing something or depositing something onto a surface usually. All right, so here's our summary. Melting is the process of going from a solid to a liquid, and it is endothermic. We have to add heat. We have to add heat. Freezing is a liquid to a solid. It's exothermic. We release heat. Vaporization is a liquid to a gas. It's endothermic. We're absorbing heat. Condensation, notice these are in pairs, right? So if you learn one, you learn them both. Condensation is gas to liquid, the reverse of that process, so you have to release energy. And then sublimation goes straight from a solid to a gas, which is endothermic. You have to give it a lot of energy. If you deposit it back in deposition, the gas goes to a solid, and then energy must be released in order to facilitate that.